All right, let's do an average velocity problem. Average velocity, v bar, is defined as total distance divided by total time. So if you have two legs or two parts to a trip, d1 plus d2 over t1 plus t2. And of course this could be extended with 3 legs to a trip. You could have plus d3 and down here plus t2 and actually out to infinity. And then you have the basic definition of velocity equaling distance over time, and we're going to use these two, the definition of average velocity and the definition of velocity, in conjunction with each other to solve average velocity problems. So you'll notice that we have a v1 and a t1, we have a v2 and a t2. So we do not have d1 and d2. However, we do have this relationship right here. So we know that d1 is equal to v1 t1. We know that d2 is equal to v2 t2. So we're going to use this knowledge in order to rewrite the definition of average velocity. So the average velocity that Joe travels in meters per second is 44 meters per second. And we have to change this to seconds, 120 seconds, multiplying 2 times 60, in order to get our units on the same, in the same system, make our units consistent. And then d2 is going to be 71 meters per second times 8 minutes, which is 480 seconds. All of it divided by 120 seconds plus 480 seconds. So we're going to get 44 times 120 plus 71 times 480, which gives me 39,360 meters. Because, again, paying attention to units, seconds cancel out here and here, and that leaves me with meters plus meters, which gives me meters. And down at the bottom, I'm going to get 600 seconds. So divide 39,360 divide by 600. Let's see. Of course, you have to key it in correctly. I get 65.6 meters per second for the average velocity that Joe has traveled at. And this is an example of a weighted average. The thing that weights it is the fact that Joe travels at 2 different velocities for 2 different times. So the only time it would be the simple average, where you add 44 and 71, would be if the 2 times were equal. And then I have a sort of an educational philosophy statement to make here, and that is, you have the basic definition of average velocity and the definition of velocity itself. And what I try to teach my students is to put these two together in the appropriate way, so that, for example, in this case, what we did was we did v1 t1 plus v2 t2 over t1 plus t2. Now let's say you were given just let's say you were given only the distance and velocity. Okay, so if you were given the distance and velocity, your average velocity would be d1 plus d2, and you don't have the times, so the times would be d1 over v1 plus d2 over v2. And then, of course, If you're given distance and time, that's the simplest case. You simply plug in your distances and your times. The problem with saying all of this like this is that I tried to get people and my students and just the public in general to stop thinking of physics as just a bunch of formulas. So now we have 3 different formulas handling 3 different cases for average velocity. Whereas my approach is to say, stop carrying around 3 distinct formulas for 3 different types of problems and stick with the basic definition of average velocity and the definition of velocity itself, and put these 2 together, which is all I did to derive these 2. Because this is time and this happens to be distance. And my philosophy is that you can really put all of the physics that you need to know, at least classically, probably, at least on a high school level, on a sheet of paper, front and back, if necessary. So just a little bit of educational philosophy there. All right. Thank you for tuning in.